I was at Penn State for 6 years. There have been many articles published about our research program. And then Arizona State University Physics Department asked me if I could come and build up their doctoral program. And then I have also written several books. These books have been well received all throughout the world and have been well reviewed in various journals. And so this is, and then of course I'm also contributing author of invited articles in encyclopedia. So the activities consisted of then giving lectures, doing research, writing books, and later on I felt that nuclear power was really detriment to the interest of human being. So I started to speak against nuclear power. So this is more or less briefly the way I'm working now.
The life history of the nuclear physicist who says nuclear waste can be neutralized and eliminated is impressive. A child protege reading and writing at age 2, completing the classic works of world literature at age 12 and beginning his study of nuclear physics at age 14. Invited to the University of London to continue his studies, a doctorate degree in 1946 from the university where he stayed for 7 years teaching and advising doctoral students, builder and director of the Brussels Nuclear Physics Lab for 8 years, lecturing throughout Europe at universities including the Sorbonne in Paris, an associate of the daughter of Madame Curie, an associate of the elite nuclear physicists in Europe, builder and director of the Penn State Nuclear Physics Lab, inventor and theoretical innovator, professor of physics emeritus at the University of Arizona, where he wrote a wide range of theoretical works with translations published in many countries, and then, as he said, he began speaking out against nuclear power.
I published scores of original research papers. Quite a few of them have been the avant-garde, as they call it. They were entirely new, especially in quantum electrodynamics, a special field of nuclear physics. And also I was one of the first person to verify certain theories of nuclear physics, which was really complex. And it was, later on, my work was also verified by subsequent researchers, especially from Sweden. So I did some significant original research. I feel good about it.
A nuclear physicist with not just impressive but impeccable credentials, who maintains there's a solution for potentially the greatest environmental crisis facing the planet, the long-term underground storage of nuclear waste. I asked Dr. Roy to explain why, in his opinion, this underground storage is so dangerous.
I sincerely believe the people who recommend to get rid of the nuclear waste problem by storing it underground, they are sincere. But there are many serious scientists who disagree with this kind of easy solutions. And the solution is not easy either. You see, those containers which contain very potent nuclear waste radioactivity, they're dissolved in solution. To extract the plutonium, they take the plutonium out. In the solution is left is these the radioactive isotopes. These are toxic. It is going to affect the containers. So eventually it is going to leak out. In addition, even when you store it, the nuclear disintegration does not stop. That means radioactive atoms continue to break down. With each breaking down of nuclear radiations, by giving beta or gamma radiation, there is generation of heat. How are you going to remove this heat for 250,000 years? Who is going to pay for it?
the director of 2 prestigious nuclear physics labs, doctoral professor, writer of works on nuclear theory published worldwide, saying that he and other scientists feel that storing nuclear waste underground won't work. Underground storage won't work because the highly toxic and corrosive radioactive decay will erode its containment and enter the environment as gas and liquid, which will grow hotter and hotter as the unstoppable radioactive decay continues. So we come down to the big question. What then does Dr. Roy say can be done to neutralize and eliminate nuclear waste?
In 1979, I thought of a process to neutralize nuclear waste. What does that mean? You see, nuclear, I sincerely believe, and many scientists believe, that you cannot simply store nuclear waste. The only way you can change you can eliminate radioactivity through nuclear reaction process. What does that mean? What is the nuclear reaction? Okay, as I mentioned earlier, the nucleus is made up of neutrons and protons. Certain combinations of these neutrons and protons make a nucleus unstable. So the fission products which are produced, they're unstable. Okay, now it is possible to change this constitution of those fission fragments, the byproducts which are formed through nuclear reaction. So, for example, let us take the case of, say, 3 of them. Cesium-137 is a type of element which is produced as a byproduct of fission. Now, this is very radioactive. It emits beta radiation. Its half-life is about 31, 32 years. That means, if you start with a certain quantity, it will take that many years before it can come to have the quantity. Mm-hmm. Now, if we can provoke nuclear reaction, let us say by bringing, say, gamma radiation, which has no charge, no mass, then it can throw away, say, 1 neutron from the cesium, producing cesium-136 from cesium-137. This has only a couple of weeks half-life. So we have brought it down from, say, 31 years to, say, some 40 years.
That's phenomenal.
And let it decay, die. It will go into a stable form. Strontium is the same way. Strontium-89, about 28 years or so half-life. Strontium-90, we can convert it through nuclear Roy process, as it is known, through strontium-89. In a couple of weeks, it will decay into a stable form. Plutonium is more difficult. Plutonium-239 has a half-life of 24,300 years. But we can use the same reaction process by bombarding this plutonium with gamma radiation throughout the neutron. So plutonium, this particular brand of plutonium, which is very potent for nuclear fission, what we call plutonium-239, can be converted into plutonium-238 from 24,300 years